this computer. Beautiful, beautiful. Okay, awesome. Thanks so much, everyone, for joining. Really, really appreciate the time, and can't thank you enough for spending some time here this afternoon to learn more about Riders and Riders Robotics League, our latest new educational esports league. I'm going to share my screen here so that everyone can see our presentation that we'll be going through during the course of today's presentation. But yeah, basically everyone, thank you again for joining. My name is Max Ringelheim. I'm going to be running a good portion of today's webinar along with my colleague here, Michelle. And very simply, we're going to be talking about Riders Robotics League, which, as the first slide here showcases, is the newest educational esports league, where students, specifically high school students, as you'll learn, can compete in these virtual robotics competitions. And we're really excited about this new evolution of the Riders technology because of its ability to complement a lot of what maybe other teachers, administrators, students are doing already in school as it relates to coding and robotics. And without further ado, we'll jump right into things. For starters, just in terms of who am I? My name is Max Ringelheim. I'm originally from New York. I've been working with the Riders team now for about 2 years. I am based in Miami, Florida these days. And very simply, I'm leading the launch of Riders Robotics League, the educational esports league you'll learn more about. I've been very active in the education technology space for the last now 6 years. I worked at a really popular ed tech company in New York City called Little Bits. I then worked at a coding boot camp called Flatiron School. So I've been very much in the thick of the education technology world on a multitude of fronts. I'm a passionate tech entrepreneur. My sort of claim to fame in entrepreneurship would be starting 2015's hoverboard fad. And I'm very excited now about, helping build the Riders Robotics League here in the States and expanding this awesome esports league out. Michelle, do you want to quickly introduce yourself? I think you're on mute. Michelle, you're on mute.
Sorry.
No problem.
Nice to meet you guys. I work as the Riders content manager. So I work on the scenarios, the lessons, the competitions, the actual implementation of that. My background is in computer science, game design, physics, and education.
Awesome, awesome. We'll keep moving through here. So in terms of what is Riders, for those of you who are new to the technology, to the company, believe it or not, it's a company based out of Istanbul, Turkey. So all the way on the sort of other side of the world from where I'm located. And the company itself, the software itself, launched in May 2020. So we're looking at basically 2 years that the software itself launched. And what Riders offers is a fully virtual online robotics IDE, right? Integrated development environment, where students, teachers, schools, whomever are able to seamlessly develop robots, work in different simulation environments, work on different coding projects, courses, lessons, etc., and access these awesome virtual competitions. We're basically allowing students and robotics enthusiasts, programming enthusiasts to collaborate, teach, learn, make, and really what today's presentation will be about, compete in these virtual robotics, think hackathons, fully virtual online robotics hackathons. And you're going to see visually what these competitions look like pretty shortly. In terms of what the mission of Riders is all about, it's pretty simple. Like, we are very much so passionate about trying to make robotics and coding education more accessible, more equitable. We believe that, different advanced robotics programs are oftentimes maybe either out of budget, out of scope for different schools, students, underprivileged, students in maybe lower income neighborhoods, whatever it might be. And we are on a mission to allow these students from around the world to be able to have more easy access to robotics and coding education. On top of that, we're trying to provide a robust project-based learning tool to the education industry centered around these robotics and coding competitions. And we really, as you can probably imagine, are a much so STEM education technology company. And we're trying to provide access to these advanced studies of things like artificial intelligence, which is the AI you're looking at here on the slide, or ML, machine learning, giving students an introductory approach to learning where these concepts come from. And it does start with, both computer science and robotics, which you'll learn shortly, how we provide this type of advanced exposure to high school students in a little bit. In terms of some of our successes over the last now 2 years, I'll pinpoint a couple of things that I think are worth noting. Number one would be back in December 2020, so about 6 or so months after the software itself launched, we actually hosted a virtual hackathon for Maker Faire Rome. So for anyone here who's live on the webinar or who will watch this afterwards, you might be familiar with Maker Faire events. And Maker Faire Rome happens to be the second largest Maker Faire in the entire world. And back in December 2020, we hosted an amazing drone flying competition, line follower competition. It was some of the earlier days of Riders, and successfully had over 300 attendees participate in this virtual hackathon. Back in November 2021, so not even 6 months ago, we hosted the Give Miami Robotics competition with over 100 attendees who were students from the Miami-Dade School District and from all around the world who were participating in this virtual robotics hackathon. And then back in February 2022, during what was Miami Hack Week, we hosted a student-oriented and high school-oriented competition called Hack at High School with over 200 plus attendees who participated in that specific virtual robotics and coding hackathon, and saw some really amazing results from each of these different competitions. I mean, one of the more eye-opening outputs, results from the Hack at High School competition was we literally got a couple of students internships at popular Miami tech companies here this coming summer through this hackathon, because as you can imagine, a lot of the students that participate in our competitions tend to be some of the really smartest, brightest students in their own said school, in their own said geography. And so the ability to connect our awesome virtual hackathons to amazing tech companies and provide that sort of talent bridge between both company and young talent is really remarkable and eye-opening, and sort of speaks to the power that this type of technology and league can offer. We'll go to the next slide here, just so you guys know, for all the audience members, if you have any questions, definitely save them towards the end. Would love to answer those at the end of the presentation. In terms of what Riders Robotics League, though, is now, right? This is our educational esports league that we have created, where we're providing an extracurricular activity for students, and it's a year-long program where students are developing their problem-solving skills, their coding skills, their robotic skills through these challenging robotics competitions and live trainings, which you're going to learn more about from Michelle shortly. The mission behind this league, kind of similar to maybe like a First Robotics or a Vex Robotics, right? We are trying to create our own world-famous league that students from around the world can actively participate in and gain experiences in the fields of robotics and coding through these virtual hackathons. And we're ideally trying to get 200 different teams this year competing against one another in these different virtual robotics hackathons. We have a focus on countries like Turkey, the US, India, Italy, the UK, et cetera, to do this in. And, I'm excited about other countries participating in Riders Robotics League after getting a chance to attend the first Robotics Global Championships in Houston, where some other countries that were represented, Canada, Colombia, Mexico, expressed some interest in Riders Robotics League. Sorry, my computer just went a couple of slides ahead. In terms of who we're targeting with Riders Robotics League, it's definitely intended for high schools that have robotics teams, or high schools that haven't had a chance to create a robotics team and can leverage Riders as their gateway into doing that. In terms of the method of participating, the method participation is pretty simple. There is a 15-hour-long skills training bootcamp, which Michelle's going to talk about shortly, that's provided to each of the teams that participate in Riders. We then have mentors who camaraderie build and help build team support amongst the team members. And then obviously Riders provides our virtual hackathon software to the said students to participate in these competitions. In terms of team structure, how is it broken up? Well, each team is supposed to be between 6 and 10 students in size. Individual participation is not allowed. We're not encouraging that for a few different reasons that I can speak about if people have questions afterwards, but it's primarily just because just like a FIRST or a VEX Robotics has this amazing flourishing league consisting of teams, we want to have the same concept taking place here in Riders. And we think there's a lot of other supplemental skills that students gain when they're participating as teams in these types of robotics competitions. And ultimately, each team is supposed to have a corresponding mentor. That mentor could be a rock star teacher at the school. It could be a teacher not even assimilated with computer science or robotics. It could be a biology teacher, a mathematics teacher. We're just looking to have there be this mentor who's corresponding to the actual student team, so that from an accountability standpoint, from a camaraderie standpoint, there's different levels of intermixing that mentor into the league with their said team. And it can even be like an amazing parent who, you know, wants to support their child and their child on this said robotics team in Riders Robotics League. So the sky's the limit in terms of who those mentors can be. In terms of the structure of participating, it's pretty simple. So very simply, it starts off with a 5-week-long training boot camp where students that complete and teams that complete this training boot camp, they receive a certificate for their completion. This is something that they can put on their resume afterwards. And Michelle is the individual, our lead instructor, who will run that training boot camp. It's about 15 hours total in time commitment for the students, where they'll be learning how to program in Python. They'll be learning how to program in an IDE. They'll be learning how to program robots in a virtual simulation all throughout this training bootcamp. After that, teams that earn the certificate will be allowed to compete in our pre-selection competition. And think of like the pre-selection competition as like round one, right? It's like the qualifier type competition. It's the first level of beginning to compete. And what these teams will do is they'll compete in these multi-category oriented virtual competitions that Michelle's going to show you some visualizations of what some of these look like very shortly. As teams are participating in these 3 different categorized competition, their code base that they submit in the competition will get automatically scored via an automated scoring algorithm. And that scoring algorithm will rank the teams from first all the way down to last in terms of how each of these teams are performing. And it's on a global leaderboard that everyone can see. And so that master leaderboard essentially is ranking every team as they submit their code. And certain teams move up and down the rankings as they're competing in the competition and enhancing their code base, enhancing their algorithm, enhancing their robot. After that, typically the competitions last a couple of days, like 3-4 days long. The winning teams, like those top ranked teams, the top 10 to 12 teams, they'll go from the pre-selection competition to our cohort final competition. And those 10 to 12 teams will then compete against one another. The top 3 to 5 teams from that cohort final competition will then later on in the year get invited to our own World Cup type competition, kind of like how FIRST Robotics has their global championships, right? Where the best of the best teams get invited to that. Same goes for here, right? So that gives you a sense of how the structure works. And here's a just better, even better visual representation of what that looks like, right? So we have these different stages of the competition. Right now, we're in the team building, right, phase of Riders Robotics League. We are actively recruiting new teams, new mentors, new students to Riders Robotics League right now. And we'll be doing that all the way up until June 25th, when our season 2 of Riders Robotics League kicks off. And so in that time period, right, there will be this 5-week-long training, which Michelle will run. It's about 15 hours again total in a full-on training boot camp. From there, students will get and teams will get about 3 weeks to take what they learn from Michelle's training boot camp and put it into application, right? They'll get a chance to practice during preliminary rounds and work on different simulations to work on what they learned from the training boot camp. That's kind of like the practice round. And then we get to that 3-day long pre-selection competition. That's like the go live date, right? Where, you're actually truly participating in an actual virtual hackathon competition. After those 3 days, we'll see who are sort of those top 10 teams that will then get invited to the cohort finals. That'll then last about 3 days. And then those top 3 or so, 5 or so teams will then get invited later on in the year to a global finals. And we're basically running these different seasons at different portions throughout the year, right? So June 25th is when season 2 begins. And then season 3 will begin sometime in September. We'll probably go throughout the fall. So that gives you a sense of what these like 3-month time periods kind of look like. In terms of some of the benefits of participating, so there's a bunch, but here's some of the top ones that we think students gain and teachers and schools gain from participating in Riders Robotics League. Number 1, there's no expensive hardware. There's no expensive travel that you have to pay for or fundraise very heavily for in order to compete, right? Everything is done from the comfort of your own home. If you look at number 3, right, you're going to get the chance, teams that is, to compete against other teams from around the world, whether that's a team from Italy facing off against a team from Turkey, facing off against a team from Romania or Canada, right? It's all happening from the comfort of your own home. So there's no expensive hardware, expensive travel you're having to pay for or fundraise for in Riders. On top of that, students are getting a chance to learn real 21st century skills in coding, robotics, artificial intelligence, machine learning. And again, like we cover Python, C++, sensors, distance sensors. Michelle will be able to talk to you in a couple of minutes about some of the different physics-oriented components that are baked into the Riders platform that students get exposure to, whether that's friction, speed, radians, velocity, etc., that are all part of the Riders technology. On top of that, if you look at number 4, transferable skills. So what do I mean by that? When I was in Houston at the first Robotics Global Championships, it was super apparent how typically like teams gain value from camaraderie, team building, communication skills. There's a variety of different soft skills that you gain in those types of competitions at first that, again, you gain here in Riders Robotics League. So that's really awesome, right? On top of that, there's also legitimate 21st century skills in the Python coding robotics world that are then transferable as well. So what did I learn in Houston at the Global First Robotics Championship? Well, typically, most FIRST robotics teams, there will be like one student on the entire team of 12 that is the coder, is the programmer of that robot. And so the ability to leverage Riders so that other team members in FIRST can learn these Python skills, learn these programmatic skills through a training boot camp that Michelle hosts over those 15 hours, and then take those skills and transfer them to their upcoming FIRST or VEX Robotics League. Like that's a huge value that you gain that right now, FIRST doesn't really offer, because typically the weight of the programming efforts is typically going on one student's shoulders in a FIRST team. You get this 15-hour long training boot camp where you're going to receive a certificate for completion, which is awesome, and students can put that on their resume. And lastly, this opportunity to win cash prizes, win internship opportunities, and prizes of that such nature is something that we've seen firsthand in Miami take place with Riders, and the ability to scale that out through this Riders Robotics League is very exciting. And ultimately, if people have questions about some of the other benefits that can come from Riders, we'd be happy to address that at the end. In terms of what some of these visual simulations look like, and Michelle is going to show you a live demonstration in about another minute or two, this gives you a sense of what the training boot camp covers, right? So someone like Michelle gets a chance to walk students through a 5-week, 15-hour long program where students are getting access to these different simulated environments, and they're learning how to program different types of robots in different types of simulated settings. And you're getting a visual of what some of these settings look like. And Michelle's going to show you in about a minute what in real time these simulations look like. While I'm just on a topic, Michelle, anything that you want to quickly add that might be helpful for some of the audience members to hear? I know you're going to show a live demonstration in a second, but anything that you want to quickly chime in on as it relates to the boot camp itself and how you sort of teach these boot camps?
Right, so I think one important thing is the students are going to be doing the boot camp and then the competitions, and it's important to understand we consider both of those pretty essential parts of the process. So this is the boot camp is where the students are really having guided learning. So I'm actually teaching them step by step how to go through some of these problems. Competitions is where they're really being creative and working together. Another important point, I think, is regarding the skill level. The boot camp is going to be very introductory programming. I would consider this extremely accessible for a student with no programming experience if they're motivated and they can sort of handle some kind of logical thinking. So I wouldn't consider programming a requirement by any means. We're going to be teaching the first level stuff in Python.
That's awesome. Yeah, no, it makes perfect sense, and couldn't agree more. So that's awesome. Thank you so much. Let's see. Our next slide here showcases what some of these different competition categories look like, right? So having students and teams from around the world get a chance to compete in a line follower race, right? Or in a drone flying race, or in a paintball competition, right? This is a prime time example of the different types of competition students are getting a chance from around the world to compete in. And just this concept of students being able to literally work on a robot, compete in a drone flying race or in a paintball competition from other teams from around the world is a really high value proposition from our side. And doing it from the comfort of their own home and not having any background in computer science, going through Michelle's training to then go ahead and then compete 3 or 4 weeks later, we believe is super valuable. And that's what's getting us very excited about launching this educational esports league. Without further ado, I think our next slide here, Michelle, is showing how the actual technology works. So I'm going to pass the baton off to you. I'll stop sharing my screen, and I'll let you go ahead and share your screen so you can show some of our audience members how the technology itself works, and give them a high quality walkthrough of it.
Sorry guys, I wasn't paying attention to my window.
You're fine. Don't worry about it. And just while we're waiting for the simulation to load up, basically on a high level, what each of the simulations that Michelle showcases are going to basically be demonstrating are a background on some of the different lessons, right, that he'll be going through during the boot camp. He'll also showcase some of the different example competitions, and you'll get a high level view of what students will be able to actually partake in.
Right. So, and also, Megan, I saw you just joined. Max is recording this so you can get caught up, but there's sort of 2 essential phases here. We're going to be talking about what the students will be doing. Right now, I just want to give you guys a flavor for what you'd actually be doing in the lessons, what you'd actually be doing in the competitions. So please interrupt me, and we can do this, dynamically if you want, or just follow along. We have right now 7 lessons for the boot camp. This happens to be lesson number 2. Like I said, lesson number 1 is really basic, where we do solve some puzzles and you're just writing 1 line of code at a time and just getting familiar with the IDE. But I want to give you a little bit of an example of what we might do. So in lesson 2, we start talking about while loops, for instance, and we'll spend a little bit of time on that. Again, very introductory programming. So I'm going to give you some idea how we'll be walking the students through here. Again, I'm sorry to load that up again. And then it would be just having some trouble with that. Okay. So here's our students' code. And guys, I'm sorry, I'm just going to bring up my example to copy it in. I was not planning to not have it loaded up for you at all, but this will just be a little faster. Riders logs out after a while. Can you guys hear me okay?
Yes, all good on this side. And for some of the other teachers that are in the audience, like Seth, what you're looking at are some of the different teacher guides. So every one of the actual lessons themselves has a corresponding teacher guide where it walks a said teacher through, actual example code that would allow a student to actually get from start to finish with their actual simulated robot, and gives you a sense of the actual lesson plan. What you're looking at here on Michelle's screen is an actual example lesson plan that walks a student through each of the different checkpoints as they're going through this particular lesson, which is called Dirt Rider.
Right. So I'm sorry for that, but I'll show you kind of how this works. So when we're doing the lessons together, students are going to start with very basic stuff. So we may begin with a very simple while loop where the student just simply does the robot and is going to do turn right. And in this lesson, the idea is to train your vacuum cleaner robot to clean the room. So in our first test, we just have this simple loop, and they're going to do a little activity, and then we'll walk them through from steps, and then they will solve some problems on their own. So the next step they might do is they would try to do, let's say, robot move forward, and then they would see how a pattern works if they move forward and turn right, and then they repeat the loop again. So now we have a little robot, he moves forward, he turns right, and then he would be looping again. And the way this works is, in the lesson, we'll be working with the students with some patterns like this, and they'll be trying to implement these. So I'll show you how to have the students set up something like this, like a simple loop going around and around. And then they'll be challenged, for instance, to try to solve the next one. So in this case, they want to drive all the way around and figure out how to make their while loop work. So it picks up all of the pink, the pink dirt on the map. And the way this works is that when we do our self-guided lessons, we also have checkpoints so students can actually see when they pass certain things. So they would have to sit here and work for a few minutes, and they would figure out that they would, let's say, go forward, 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 and then they would turn right. And you'll notice every time I'm changing the code, I'm just hitting reset here. And then now we can see the robot's going to go forward, 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 and then turn right, and then continue. And the way the lesson would usually be progressing is that we would have some examples where students would essentially be copying me. So, and then they would be given a challenge for a few minutes to work on, and then we'll come back and we'll review that and we'll discuss that. So there'll be a lot of back and forth, a lot of opportunity in the lessons to try things. And the final challenge for this would be to actually try to have the vacuum cleaner clean the whole room. And there's some different patterns they can do for this. And there's interesting stuff for a beginner student to learn. For instance, they can turn right, but they can also use forward and backwards moves and so forth. So
and the concept here, right, Michelle, is they're taking these programmatic skills and learning them, even if it's introductory in the beginning, setting themselves up for a couple of weeks later when they're going to be actually in a competition environment, which I know is what you're going to show next. But it's these transferable skills that are going to then all of a sudden be applicable in a competition setting.
Right. And you guys go ahead and ask questions if you want, or we can ask questions afterwards. I'm just going to start loading up second project so that I can slow down the loading time for us. This is a project we called Line Rider. We have probably hosted, I don't know, dozens and dozens of different Line Rider competitions. It's a simple concept, and I think it's one of the most successful competitions we do in some ways, because just from the amount of time students will spend on these projects. I mean, sometimes it's just stunning. They'll literally do thousands and thousands of entries trying to fine tune these courses. So the Line Rider problem involves essentially following a line, and there's many variations. We have like 3 line courses. We have courses, competitions where cars have to avoid each other and so forth. But this is what I would consider our sort of basic vanilla introductory line competition. You can see in the IDE here that, let me make this bigger for you. We can go to the camera here. I'm a little trouble with my browser, but let me get this going. So here's the camera. Now in this one, the camera is just a one-dimensional line, and I mean a one-dimensional camera. So the pixels, there's only 32 pixels across, but I just stretch it vertically.
And real quick, Michelle, I just want to call out, like, for those in the audience that are just seeing Riders for the first time, inside of the rider simulator, there's, I think, about a half a dozen or so different cameras when it comes to this particular lesson and this particular, there's line follower competitions. The robot that you're looking at in the bottom left-hand corner of the simulator actually has a camera on the front of it. Michelle, if you want to zoom in just so that people can see that, camera on the front of it, that'll then just like help bring to life what this streaming, live data is going to be providing, the student with from an output perspective, an input and an output perspective.
Right. So let me, and again, this was that unfortunate reload. I'm just going to grab the.
No worries. This particular competition tends to be one of my favorite because of the fact that essentially what students are tasked with is having to understand the beginning fundamentals behind image recognition software and understanding how an actual camera can capture different pixels worth of data and different color spectrums and color actual colors within an actual camera setting. And so that information gets spit out into the terminal of the actual rider's IDE, so that students can actually understand whether or not their robot is following this line properly based on the color of that white line inside of the simulator that Michelle was just inside of, that I'll be back in a second. But that's what Line Rider basically allows for students to get an introductory sense of image recognition software and understanding the color spectrum and how a camera can actually provide a robot with real feedback to know if it's following this line properly or not.
All right, guys, so I'm just skipping ahead here a little bit, but in the lesson, we're going to set up students with sort of a feedback algorithm. So the idea is that they'll be set up with the ability to set the robot speed and also the gain, and then they can actually control their robot to actually follow the line around. And the issues that come up are as they go faster and faster. For instance, in the lesson, right now they want to go around as fast as possible, so they might pick up the speed a lot. Let's say they try something very fast just to go faster, and then we can see what happens. And then they have to start tuning the algorithm with the feedback. So feedback is a very complicated concept with stability and so forth, but they can really learn about it at a very basic level because they only have to tune two numbers in this project, just the speed and how fast the robot turns. So there you can see it lost the line because it's just not turning fast enough to track the line. And they might make their rotation speed faster, and then they will start experiencing the instabilities that come with feedback. And you can see the robot starting to wobble a lot and so forth. So there's all kinds of strategies for how you can deal with fast track and the curves and so forth, and different ways that might go about that. So actually, Max, I lost track. How are we doing for time here? Can we do one other one here?
Yeah, no, totally. We definitely do one more.
I wanted to just give you guys, so those are two lessons. I want to give you guys an idea for the competitions as well.
And as a refresher for some of the new folks that joined late, these lessons that Michelle just went over are compounded together in a 15-hour-long training boot camp where the students show up on Zoom, get instructed by Michelle through these different lessons and projects. It's a total of about 15 hours. And from there, take those learnings and then apply those learnings inside of a actual virtual hackathon, a virtual hackathon competition where they're taking these same skills that they learned during the boot camp and applying those skills in a competition similar to what Michelle is about to show here with our robotic arm competition. And they're going to do this all from the comfort of their own home in team capacity against other teams from around the world.
So in this one, we can, there will also be a lesson with this arm. So in the Line Rider, we had a one-dimensional camera where we start introducing the students to the idea of pixels and sort of how to deal with an array of data and things like that, which is a big step. And here we will actually walk them through the steps for how they would actually analyze an image. So the robotic arm has to sort these items into different, not sure what's going on with my browser today, but just can't split my windows today. There we go. All right, so you can see now the items are coming in on the conveyor belt, and the idea is that they have to sort these into different positions. So there's a camera on the right side. So we teach them how to go through the steps to do a selection process based on the color of the item. And you can also use keyboard control to sort of play around with the robotic arm, and you can save different positions. So it's sort of a nice dynamic way for them to get a little bit of an introduction to kinematics, and they can find positions to drop the items into the different bins. And so we do a competition as well. And this is a really nice competition because what happens is that, you know, at a very basic level, you can get the basic problem solved, but you can really make the process parallel. So you in your code, you actually can control everything in this one. So you can control how long the robot sleeps, when the conveyor belt turns on, when a new item comes onto the belt. So you can send the items extremely fast. So students come up with some really interesting things. I mean, they get the items just coming out like crazy. We had a student actually like throwing items with the conveyor belt up in the air so that it would save time. So all kinds of stuff. So it makes a really interesting sort of team project. And this introduces them to 2D imaging as well. So we do a lot of work with image processing. And I guess, Max, I don't know if we have time to look at one more because of the little.
Yeah, no, if you want to do take another 2 minutes to do one more, and
Sure.
while you're loading it, I'll just comment on, you know, essentially, guys, imagine a competition around that robotic arm scenario where each of the different students and the teams themselves that the students formulate are competing against one another to see who actually and whose code base was most successful at, you know, properly sorting the different items coming out on the conveyor belt properly, right? That's what you can then imagine a competition doing, and essentially having a master leaderboard that's scoring the team from Italy versus the team from the UK versus a team from Florida, and their ability to create a 2D imaging algorithm that can properly sort these different packages that are coming off the conveyor belt. So that just gives you a little bit more of a visualization of how they're taking the, you know, lessons learned from the training boot camp, applying them in a competition setting, and seeing who and whose code base is actually most successful. Which one are you going to show up last before we wrap up with the demo?
So this one, I just wanted to show an example. This is actually a solution that students found in their final, you know, the cohort final after doing the individual categories. So it's just kind of fun. The idea of this competition was to have a little, in a little factory, your robot needs to drive around and pick up boxes, and it needs to deliver them into the bays. And I've got a code loaded up from a winning solution before, so it's kind of fun to see what the students actually came up with. So this competition sort of synthesizes a lot of the things we've been doing in the lessons and the previous competitions. So students in this one can use a camera, and they also use some feedback concepts because you have to turn and line up on the boxes and then drive forward. You can't drive too fast or too slow. Let me reset that so we can watch it from the beginning. Yeah, the student's solution doesn't always work, but because you're allowed to reset in the competitions, you don't have to have it perfect. But his solution worked well enough that he was able to get a really great score. So he actually finds all the boxes and he has to deliver them on these days.
And I mean, Michelle, maybe it's just a cool time to also mention how, like, the fact that students are truly programming in an authentic, integrated development environment gives them the opportunity to, like, take some of the feedback that they might get from the terminal, right, and actually modify their code via debugger, et cetera, to, you know, enhance their code base after maybe submitting, you know, a first time, seeing what their score was, and then using that actual terminal and the actual sensor data, feedback data from the terminal to modify their code and make some different enhancements to it.
Right, and I think that's a really important point. So it's different than a live competition, and it's what I was mentioning with these line follower competitions. Actually, many of them, students will come in and they'll try something, they'll run it, they'll get a bad score, they'll run it again, they'll get a better score, and they'll really get motivated. And then we have one student, and our top scores will have sometimes thousands of entries. I mean, they really just sat there and just kept trying and trying, and they found these sophisticated ways to improve their score. So you get this wonderful feedback, because all of our simulations usually take about less than a minute even to run to get your score, once you have something working. So there's this really nice turnaround time where you, just like Max was saying, you fiddle, you run it, you get a score, you see it on the leaderboard, which I always think is a great motivator, and then you're back in your code again, making changes.
I think the quick thing I would add on that is, like, the way that a lot of teachers have described it to me, Michelle, is instantaneous feedback that you can get by submitting your code, having it run on your robot instantaneously, and then making modifications there afterwards. And when you get that instant type of feedback, sort of a bit of a stickiness factor takes hold, where students want to, like you said, spend 10 plus, 20 plus, 30 plus hours trying to get the highest score on the leaderboard possible, because they have this ability to continue rerunning their code multiple times and iterating off of it, refactoring it, etc., to try and do as best as possible in this virtual competition.
Yeah, I mean, that's really, for us, the ultimate is when we get to that point and we've taught them some things, and then they just start going at it, and it's just awesome to see that.
Yeah, no, I agree completely, and it's something that we've definitely seen on multiple occasions. So why don't you hand back over the screen share to me, and I'll wrap up the presentation. We'll just take some last Q&A if there is any. So where I wanted to go from here, if I can find my presentation, give me 1 second. Here it is. Okay, cool. Let me just exit out of full screen and come back into screen share mode. Can you guys see my screen here? Is it back up live? All good. Michelle, can you see it? Cool.
It's there for me.
Awesome. So what I just wanted to wrap up with, and we'll take some final Q&A, is very simply, when it comes to participating in Riders Robotics League, very simply, it is a $199 per team member fee. And for that $199 per team member, you're getting access to this 15-hour-long online training bootcamp. You're obviously getting full access to the Riders software and full access to participating in Riders Robotics League as a team. And so if you want to think about it in like whole terms, right, we're looking at like somewhere in between, or approximately $1,200 some odd dollars or so for 6 students to participate on a team. In the early portions of Riders Robotics League, if there's a team of 5 that wants to partake, we're not going to shut them down from participating in Riders Robotics League. Just know though that you're looking at about a $1,200 cost or so per team to join. In comparison with that of a FIRST Robotics team, right, where that FIRST Robotics team might be literally raising $15,000 to $20,000 to accommodate for the hardware they're going to need, to accommodate for the troubleshooting they're going to need, to accommodate for the hotel and travel and airline tickets, etc. they're going to need for traveling to regionals, to semifinals, to globals, etc. We feel like this is a very competitive rate for teams to be able to participate in a virtual robotics league. And the entities that can subsidize, Riders Robotics League or a particular team can totally vary. It's designed to be an extracurricular activity, right? So a parent can subsidize the cost for their child instead of maybe, paying for gymnastics or tennis lessons, right? If their child wants to partake in a robotics league, in a coding league, here's their opportunity to do that. And so whether it's parents, institutions, the schools, a company sponsor, the student themselves, paying for this, there's obviously different entities that can subsidize what we believe is a very cost-effective solution here. We're also providing an incentive to mentors and coaches who want to coach these teams. So as an example, we're providing up to $300 to each mentor / coach who wants to mentor slash coach that said team from that school or museum or wherever it is where the team is assembling to create this team on Riders Robotics League. And it's up to the mentor's discretion how that money can be used. If they want to pass through that $300 to their team members, these 6 to 10 students, to get a additional discount, that's totally cool. If they want to use that $300 towards a hardware purchase for their upcoming first robotics league, that's totally kosher. If they want to use it as their own little stipend for providing the camaraderie and time dedication to the students, that's totally kosher as well. And the people that are eligible to be mentors can be anyone from an actual university student, a parent, a teacher, a community leader, whoever it might be. Those are some examples of who mentors can actually be. So I invite any of the adults here on today's webinar, who are thinking about joining Riders Robotics League and spreading the word to their students in their school to actually take up this opportunity to be a mentor or coach for that team. In terms of the presentation, that's all we have for today. So this is the end of our presentation. We've got about 10 minutes or so for Q&A. If you're interested in joining Riders Robotics League or you have any questions about Riders Robotics League, you can email me, max@riders.ai. I'm happy to put my cell phone number in the chat as well if someone wants to reach out via phone. The actual landing page where teams, mentors, students, etc. can sign up is riders.ai/arena/riders-robotics-league. And that is our landing page for our competition here at Riders Robotics League. So feel free to check that out. I'll actually put the URL here in the Zoom chat. If you guys want to check that out right now, you're welcome to. And again, take down my email and I'll post my cell phone number in the chat in case anyone has any questions afterwards. But without further ado, here's the landing page link. And here is my cell, as well as my contact info, email, max@riders.ai. Does anyone have any questions that they want to pose? I know we've had a chance to go through the whole presentation, so thank you all so much for listening, for joining today. Truly means a lot because you guys are some of the first early champions, take a liking to our awesome software here, specifically when it comes to our new esports league. So we'd be happy to spend a few minutes answering any questions if anyone has. Go ahead, Andy. Yes, feel free to unmute yourself.
Hi, Max.
Nice to meet you. Thanks so much for joining.
So I have a small team, and I'm not sure I'm able to assemble 6 students.
Yep.
I might have 1 or 2.
Cool.
If the school approves. So is it possible to form a team with other schools?
Absolutely. Yeah. I mean, it is totally fair game, Andy. If you wanted to recruit a couple of students from a separate school, 100%, that's totally kosher. This is not a school versus school competition as much as it from a first perspective. It's a different teams assemble and compete, right, in a sort of semi-decentralized, we'll call it, competition type scenario, right? So if you only had 2 students from your school and you wanted to try and partner up with another teacher from a different school to create a sort of inaugural team, that's totally kosher. And if you only found, let's say, 4 students total, we would not be sticklers to saying, oh, it has to be 6, where we would absolutely invite them in to join.
No, but I mean, is it possible for you to, since you have the list of other schools and how many students, would it be able for you to help us matchmake, let's say, different schools together?
Absolutely. Yeah. I mean, from our side, just to be clear, Andy, we are actively recruiting the first US teams for season 2 of Riders Robotics League, which starts June 25th. So we're in active recruiting mode right now. For example, season 1 took place in Q1, but it was specific only to Turkish teams. So we ran our first Riders Robotics League season in Turkey with purely Turkish teams. Season 2 is our first opening of US, other country specific teams into Riders Robotics League. And obviously we can talk further about who some of these other potential prospective teams, teachers, students are that are thinking about joining. But just know that these are some of the earliest teams participating because Riders Robotics League didn't exist before now, right? We were hosting, Andy, individual virtual hackathons in February of 2022, in November of 2021, in December of 2020, but these were individual oriented hackathons because our team concept and functionality didn't exist at that time. Is that clear? We didn't offer teams competing against teams in the months prior because that functionality is fairly new.
Okay.
Yeah,
Thank you.
You got it. I think, Seth, did you have a question?
Yeah, just kind of a question about coming from this more of an educator standpoint. How is the system going to work or look like? How would that look like? With the boot camp, would that be something that I would set up with you guys to have, like during our specific elective time for my robotics teams? They would come into the boot camp for that time, 3 times a week or whatever, for however long, for an hour or so, to get that, what was it, 15 hours over 5 weeks?
Yeah. So I'm just going to repeat back the question to make sure I'm answering it properly. Is your question primarily, if I wanted to leverage riders inside the classroom, as well as maybe have a team that wanted to compete in these virtual hackathons, how would I sort of set that up, right? Is that more or less the question?
More or less, yeah.
Okay, cool. And obviously we can talk offline to get the exact answer you'll want, but the way that I would answer that is the following. We have over 40 to 50 hours worth of lesson plan guided instructional material. If you wanted to take all of those, it's about 15 different lessons, like you saw a couple of them today. If you wanted to leverage that material in the classroom during one of your elective periods, you absolutely could do so. If you want to then take some of the students that are in that elective and formulate this 4, 5, 6, 10-person Riders Robotics League team, they would then get on top of that a separate opportunity to learn from Michelle some of our specific 15-hour-long training, which would be guided by Michelle. You should look at those two concepts, though, Seth, as mutually exclusive. You should look at Riders Robotics League as being an opportunity for your students to participate in a extracurricular robotics team activity. And then you should look at your usage of riders in the classroom as its own separate pathway. Does that make sense?
Yeah, that makes a lot more sense to me now.
Cool. Any follow-up to that? Or I think Megan might have had a question, or do you want to ask a follow-up? Cool, go ahead. Megan, did you have a question? I think I saw a hand raised, but if not, no big deal.
Yeah, I mean, it was kind of by accident, but that's okay. Thank you so much, Max.
Okay.
How you doing? Quick
you.
question. In terms of the Miami market, do you guys have a directory of what schools you're already in Miami?
Yeah, so there's a handful of different schools that are expressing a bunch of interest in participating. Jose Martin Mast Academy, which is a school where the robotics teacher is Carmen Garcia. She was one of the most successful teachers with riders so far. We've got an individual named Sean Waring over at Central Miami-Dade High School. Miami Beach High School as well is expressing interest. Booker T. Washington School is expressing some interest. So, there's an array of interest and excitement.
I'm just trying to see like where I overlap so I can strategically introduce you to some schools that I already know.
Yeah.
Specifically like Carrollton, Ransom,
None of
Palmer
those ring a
Trinity.
bell. None of
Okay,
those ring a bell.
perfect.
Yeah.
All right.
Absolutely.
All right, I'll connect you with them.
Does the concept make a lot more sense now in your mind, Megan? I think I might have told you about riders a little while back, but
Yes, it does a lot more sense.
Cool.
And I know that we had talked about esports. Are you guys seeing any synergy between this and like collegiate scholarship money or opportunities out after high school?
Yeah, I mean, the opportunities are endless, right? I mean, the concept of being able to provide an educational esports league for high school students where you learn a lot of awesome competitive soft skills in a League of Legends, tournament. But if we can take those same esports pillars and apply them in a virtual hackathon setting that takes place quarterly and, allows hundreds of thousands of students to partake in, like obviously the same type of scholarship opportunities and whatnot that exist in a esports league can all of a sudden be transferable here in an educational esports league.
Yeah, I love that. And like specifically, my question is that I'm currently working with 2 teenagers who like don't even think about college, but they're very into this. So
Yeah.
I think I can leverage them to even start it at their schools. They're in California.
Exactly, no doubt. I mean, the students that thoroughly enjoy programming, the students that have an itch to become a software developer or to become a roboticist or a computer scientist, like this is a way for them to take some of the skills that they've learned over the last couple of years, maybe in middle school and high school, and flex those skills in an actual competitive environment, and then showcase those said skills on a global level, let's say to prospective employers, right? If they can say they made global championships at Riders, just like how the same team that won first robotics in Houston 2 weeks ago, it's the same concept. You can advocate for that as well.
Okay.
Yeah.
Thank you very much.
Cool. I know we're at the hour. I want to be respectful of everyone's time. If there's any other questions, I put my email and phone number and landing page to Riders Robotics League in the chat. So copy and paste each of those. Seth, Andy, Megan, Meta, we'll follow up afterwards and really appreciate it. I'll get this on YouTube very shortly so that you can share this with any other colleagues, connections, etc., who you think might be interested. But what I can end with is that we've definitely seen some really fantastic results with some of these, competitions that we've run to date. And now we're packaging this in this league, structured, organized league capacity. And I think the sky's the limit for that. Awesome. Michelle, anything else you want to add, or you think we're good?
I think that sounds good. Thanks very much, everyone.
Thank you so much, guys. Appreciate it. I'll close out the webinar, and I'll look forward to following up with y'all afterwards. Awesome. Let me stop the recording.